Hello, my name is Ian, and today we are going to learn how to solve the square one. Now, this puzzle only has 435 trillion permutations, but it's a tedious puzzle, so get ready for a long solve. Now, there are 7 steps to the solve. First is cube shape, second is corner orientation, third is edge permutation, corner permutation, edge permutation, parity, and then final solve. Now, this is what a square one algorithm looks like. It's a lot different than a regular Rubik's Cube one, and I will explain it. Now, these slashes mean a full cube rotation, and these numbers represent how many degrees you're going to turn. 1 stands for 30 degrees, 2, 60, 3, 90. So these large pieces are 60 degrees, or 2 numbers, and these small pieces are 1. So this algorithm would be slash 1, 2, 3, slash -1, -2, -3, -1, -2, -3, slash 0, 1, 2, 3, slash. Now, slash 1, 2, 3, clockwise because it's positive, slash -1, 2, 3, counterclockwise, -1, 2, 3, slash 0, 1, 2, 3, slash. Things to remember about these algorithms: the slashes are cube rotations like this. The first number represents the top layer. If it's positive, it's clockwise, negative counterclockwise. The units are 30 degrees. Large pieces are 60 degrees. Small pieces are 30. Just remember that. You'll be fine. Alright, so now let's scramble the puzzle. Now, the first step of this puzzle is to get it into this shape, which would be like so. Where all the edges are touching, there are a bunch of corners on the bottom and 2 edges up here. Now, we're going to use our first algorithm. So, it's slash -1, 2, 1, 2, 3, 4, slash -1, -1, 2, slash -3, -3, slash. Now, the first step is done, we have our cube shape. Now, getting the original shape before you do the algorithm can be hard, but it should be purely intuitive, and once you start practicing it more and more, you should be able to get it like that. The next step is to get the white corners and the yellow corners on their respective sides. This can be done fairly simply. Instead of turning it like this, where it destroys our cube shape, we have to offset it 1 and match the corners together. See? Bring this with this, so they're together, and then we're going to bring these corners down to this side, offsetting 1, slash, and now all the white corners are on their side, and all the yellow corners are on their side. Now, a trick I have is I like to keep the white bar on the bottom, and then pair up this uneven side by just matching it with this yellow bar here. And you see, when we bring up the white-yellow, we have white-yellow on the opposite side. So a case like this wouldn't work because white-yellow, when we pair it up, it's going to move the white-yellow out of the way. So the yellow and the white bar are opposite sides, and the 2 conjoining corners are going to be on opposite sides. Match them, and then insert them, like so. Now, there are 5 cases for this. The first one, which is the simplest, is this, where we're just switching these edges and these edges. And let's learn that algorithm. Let's call this case A. So, this is the algorithm. Let's quick perform it. Notice that there is not a slash before these first 2 numbers. So, offset 1, slash, -1, -1, slash, 01. And there we go. Now, you're going to start to notice a pattern that basically case D leads to case C leads to case B, and case B leads to case A. So just keep that in mind. This is the final and easiest case. Now, this is the second easiest case, also known as case B, with the L on top, L on bottom. Now, let's learn that algorithm. Now, this algorithm will bring this case B, to case A. They have to be in this position. I like to make sure by having the small piece on the left-hand side. So let's do that algorithm. /3 slash -3 -3 slash 0 3 slash. And then we have case A, and there we go. Now this is case C. It's almost like a combination of A and B. But again, small piece on the left, it's the exact same algorithm as case B. So let's do that. Slash 3 slash -3 -3 slash -3 slash. It's going to bring this piece to this side, so we're just going to put it in the correct position. Slash 3 slash -3 -3 slash 0 3 slash case A. There we go. Now this is case D, the final and hardest case. Basically, it's algorithm for A, algorithm for B and C, algorithm for B and C again, and then algorithm A. Basically, you have to make sure it's set up like this, with the pieces in the correct position, relative to the left-hand small piece. So, algorithm for case A, case C, case B, case A. There you go. Now this is case E. It's basically case A twice. So case A once brings us to a regular case A again. Now there are many possibilities for this final corner permutation, but I'm just going to talk about the three most common. Now the one that we have here is bar diagonal. So these pieces need to switch and these pieces need to switch. So let's learn the algorithm for that. Now this algorithm is very fluid and easy to do. It's slash 0 -3 slash 0 3 slash 0 -3 slash 0 3. And it's going to fix all the corners on the top and the bottom. Now this is the next case, the bar case, where these two corners need to switch and these two corners need to switch. Luckily you already know this algorithm. It's the algorithm for cases B and C that we used in the last step. So slash 3 0 slash -3 -3 slash 0 -3 slash. And all the corners are fixed. So this is the next case that you can get where diagonal and diagonals need to switch. And basically it's the last case that we did twice. So let's do that algorithm. Find the bars and line them up so they are in front. Do the algorithm again, and there we go. All the corners are solved. Just as a precaution, if you get a case like this, where the bottom is already solved, but the top is not, and you have a bar, basically, you just put that bar in the back, do the algorithm that we learned for bar diagonal, then find the newly formed bar and do the algorithm again. Now, just like the beginner's method for a 3x3 Rubik's Cube, we're going to use U-perms to get the edge permutation correct. Let's learn that algorithm. Now, just like the beginner's method for a 3x3 Rubik's Cube, we're going to use U-perms to get the edge permutation correct. Let's learn that algorithm. Now, the difference between the UA and the UB perm is very simple. Basically, if you want the pieces to switch like this, you have to start your original turns by... See, this piece is going to go here because these two pieces are turning. If you want it to be the opposite direction, you offset it 1 and then turn it so these two pieces are turning. If you turn it like this, these two pieces will switch, these two pieces will switch. Keep that in mind. Now, let's perform the algorithm. We need this piece to go here, so we're just going to start it off where these two pieces are switching. So, -3, 3, -3, 3, and since we did it here originally, we're now going to offset it 1 and do it on the other side. So there we go. We have done a U-perm. Now, this is the opposite case, where this middle piece has to go here. So we're going to start with an offset at 1. So these two pieces, this goes here, they switch. So offset 1, perform the algorithm. And since we did it on this side, we have to do it on this side. There we go. Now, you might notice when solving the other side that it is impossible to solve it with just a U-perm. This is known as parity. Now, if you're solving and you find parity on the first side, I implore you to solve the other side first, because you might have two sets of parities, and fixing both of them at once is much easier than fixing one at a time. So this is an example of having double parity. So having parity on this side, you have to switch these. Parity on this side, you have to switch these. Fixing that is very simple. Let's learn that algorithm. Now, we have our double parity. We set it up by putting the parities on the back and right side. So back and right, and performing the algorithm. -2 slash 3 0 slash -1 -1 slash 2 -2 1 slash, and solved. Now, sometimes the parity will show up as a piece here and a piece here need to switch. This isn't the case obviously now, but to get it into this case, just do a U-perm. Now this is the single parity algorithm, and it is a pain to memorize, but it really has to be done. So just take a while, write it on your arm, just get this memorized, or else you're going to be unable to solve at competitions. And just saying, I don't recommend this method at competitions. This is strictly just get to know the ropes of how it's solved. After that, you can move on to more advanced methods. There will be a PDF in the bio description below. Alright, now, let's perform this algorithm. I basically learned this algorithm by going off of the shapes rather than the actual numbers themselves. So just recognizing the shapes allows me to get the parity done. So memorize it and just get it done from there. Now, all your corners and edges are correct, but you might get to a case where this seems to happen, where a piece needs to be flipped here. Super simple fix, just slice, turn it to the opposite side, slice, opposite side, slice, opposite. Now, or you might get a case like this, where these are all correct, but these two need to be switched. Basically, slice, turn the middle layer twice, slice again, and then just fix.
I hope we were able to solve your square one now. If you have any questions, please comment them below. And if you have a cube that you would like to see a tutorial on, please also leave that below. Thanks for watching, and I hope you enjoyed. For those who are interested, this is a cheese squan, which you can buy at Speed Cube Shop. The link is in our bio.